Namaste, welcome back to Stithapragna, and you are watching AWS real-time cloud projects. As you are already aware, we are in season 3, and in season 3 we are doing projects for the data analytics role. In season 1 we did the projects as cloud practitioner role, and in season 2 we did them as solution architect role. And currently we are in project number 9. So this project is going to be about real-time data processing. In previous project as well, we did do a streaming related project, which is we ingested data from a streaming application, and the service we used was Kinesis Firehouse. So in this project as well, we are going to do real-time data processing. And I did start this project yesterday, and I almost went to the ending. We are almost done with it, but my recording I had to delete it for some other reason, so we are here again. So once I start the project, you might not be seeing the entire conversation since I already started it yesterday. But what is this project about? Well, the city administration wants to improve the efficiency of its wind farm. When a wind generator fails, it takes a long time to identify the fault, then send a maintenance team, and then carry out the repair. The administration wants to anticipate possible defects in the wind turbine to provide preventive maintenance. It's kind of similar to the use case with the gas station, right? When a particular gas station is out of gas, no, it should be automatically informed to uh, the people who bring or refill the gas. Similarly, here it's about the wind turbines, but the use case here is when we when the wind is too high and when there is a probability of malfunctioning, that causing and failure in the turbine, it should automatically inform the maintenance team so that they will get a message, then they'll come and handle it automatically. So basically that's what we are doing. And in order to do that, I mean, once we finish this, what are we going to learn? We are going to deploy Kinesis data streams to ingest data. Previous project we used Firehose. Then we are using Kinesis data analytics for Apache Flink application to detect anomalies. Anomalies are, things like which are not normal. So if the wind is too high, etc., so we will obviously will have anomaly score written in our logic. So when that score is above a certain limit, we call it an anomaly, etc. But we are going to that is being handled using Apache Flink application. And this is all real time, right? So as the data is streaming, this application will detect the anomalies in real time. Then it will write the application output records to a configured external destination. So we are going to use Lambda, Kinesis, and DynamoDB. So let's click on start. And as usual, we have the diagram steps and video concepts. Go through these video concepts since we are also going to use SNS to get the notifications. Then we are going to use Lambda, Kinesis, and DynamoDB. As usual, you know where to find these videos, right? I'm not going to play them here, but you can go to our YouTube channel and in the playlist, I mean, obviously this will look different to you, but in the playlist, if you come to a certain playlist called AWS tutorials for beginners, there are plenty of videos. All these videos are actually from here, right? So all you have to do is check the title, then this title with this after the pipe symbol, whatever the title, it will be the same name whatever you are seeing here. Go watch it on our channel and then come back and watch the remaining part of this particular project. I would recommend, if you don't already know those services, I would 100% recommend you to go watch this. And these are fun videos. More, they are like 3 to 4 minutes long, that's it. And they explain you these services with pictures. I really like the way they explain it, so I would recommend you go watch it. All right, once that's done, come back. Let's look at the diagram steps. So what are we doing in this particular project? So this particular project uses managed Apache Flink for real-time processing and detection of anomalies in wind speed data for preventive maintenance on a wind farm. Overall, that's what we are going to do. So wind speed sensor data is sent directly to Kinesis data streams, a service that collects and processes large streams of data records in real time. Then Flink application processes and analyzes the data from data streams. And what is a Flink? Flink application, it is a Java or Scala application that is created with the Apache Flink framework. And then we use the random cut forest algorithm. The Apache Flink application performs an anomaly detection process on the data from the wind turbine sensors. The process assigns an anomaly score, as I mentioned, to each record based on values in the numeric columns. A record is an anomaly if it is distant from other records. Then once we do that, Lambda function is set as the external destination to the data analytic application or the Flink application. The function code takes the process data and parses it into records in an Amazon DynamoDB table. The data includes the wind farm location, wind speed, and the assigned anomaly score. So yesterday while I was doing, I found out a bug in this Lambda code, which I will explain you when we get there. So we might not be getting the same results as this lab. Okay. And then a second Lambda function scans the DynamoDB table and filters for anomaly scores that are greater than or equal to 2. For each discovered anomaly, the function publishes a notification message to an SNS topic. So technically, once we have the data in DynamoDB, whichever ones has the score greater than 2, or actually I think they put it as greater than or equal to 3. So this Lambda function, what it does, it sends a notification to the SNS topic. And for each anomaly, subscribers to the SNS topic receive a notification email. In this case, the maintenance team is alerted and dispatched to the wind farm. In that, so you got it right. You will get the wind turbine data using data streams. Then Apache Flink analyzes this data and finds out the anomaly. And those anomalies data is sent is read by Lambda and puts it in DynamoDB. Then we have another Lambda function that actually queries data from DynamoDB only when that anomaly score is greater than, it said 2, but I am thinking it is 3. I checked the Lambda. They have serious problems with this Lambda. And once whatever records satisfies that condition, I think then it will send it to an SMS topic, and whoever is subscribed to the SNS topic gets emails. In this case, we are going to subscribe to that notification email. So once it satisfied that greater than anomaly score, we should get an email. So let's go to our plan and let's see our practice lab goals. And we are going to deploy data streams to ingest data from streaming data sources. And then we are going to create an Amazon Kinesis data analytics for Flink application to processing incoming streaming data. And then we are going to use AWS Lambda to write to destination. Since I already did this, I know. So the data, obviously we are not going to connect to real-time wind turbines. They have an EC2 instance. On EC2 instance, they have deployed a web application wherein we can give the Kinesis data stream once we create it. All we need to do is give its name, then hit a button, then it is going to generate the wind turbine data and it is going to send it to our stream. And once that is done, they already have built the Apache Flink application. All we have to do is while creating this application, we need to pass that jar file to this. So it is set, so we don't have to code Java or Scala. And this function already exists. All we have to do is make some modifications so that this will get triggered automatically by the Apache Flink application or Kinesis when there is data in it. And these tables are already created, so nothing much to do there. This Lambda exists. So pretty much all we have to do is create these data stream, create the application, and then create as a SMS topic, and then it's already there. All we need to do is subscribe. All this already exists, so we are not going to do much. And as DIY, we are going to create another streaming application, and even they have the jar file even for that as well. All we need to do is create an application, point that jar to this, and then this Lambda exists. We need to make sure that this works properly, and sends data to this and it will put it in the DynamoDB. So pretty much that's all we are doing in both. So let's click on the practice. Let's start the lab. And since I already did this, I know most of the steps, so we'll go fast. So first of all, we are going for S3. The reason is because this Flink applications, as I mentioned, they are already there, 2 jar files. And again, don't forget to read the concept. Even though I'm going forward, I want you to pause it and read the concepts. And these are the 2 Flink applications. They already wrote it and zipped it as jar files. This is for the practice lab. This is for the DIY. And then we are going to that EC2 instance that I spoke about, where they have a web application. All we have to do is pass the data stream that we are going to create and submit, and then it is going to uh, send random wind turbine. It will generate turbine data and send it to the Kinesis data streams that we are going to create. And once we do that, so this is how we are going to create the stream. And once it is there, we will go back here, give that stream name, submit it. Then it is going to click start, and then it is going to uh, this is just a test data how it looks like. But once we hit the start button, just to review, I guess I think we didn't hit the start button yet. And then we are going to create a data stream. This is going to be for the anomaly detection application, similar anomaly detection stream. And once it is there, we have to create the Flink application. So go there, streaming applications, create. We are going to do this, so don't worry about it. Create from scratch, and they are recommending us to use Flink 1.15. Then we are going to select the service role which they already created, and we are now going to name it however they are telling us to name it. And then templates as development, because this is for testing. Then once it is ready and we have the ARN, we have to configure more things, which is like the bucket where we have the jar file, and then we have to, there is no change here, and we will pick the bucket, and then we'll give the application the jar file name that we have picked previously. And then we are going to give some runtime properties. For example, we have to tell it, that particular Flink application that wrote it in Java or Scala, that what is my input stream name and what is my output stream name and which region. So obviously input stream is the wind data stream that we are putting data, output stream is anomaly detection stream. And then we will save changes. Once you save changes, we will trigger this. And once you trigger this, we are going to actually feed data into this. So that data will come from the wind speed data set. So we'll click on start. So it will keep sending data to what? The wind data stream. And that once the data is in there, then our Flink application will get triggered. Okay. So you can see anomaly detection. So the data will keep flowing into this. Why? Because the Flink application it is already running. And what is the input for that? Wind data stream. And we just put data into that. So it will automatically put the data into anomaly detection stream. So once you go there, you should be able to see such data in here. And then we are going to come back here, and this is just normal data. Now we are going to put some anomaly data set, which is like has that anomaly score. Okay, so review it, and again we don't have to come and check that out, but we have the data, but we need to put this data in where? DynamoDB. So how are we going to put that? This analytics destination function does that for us, but it should get triggered automatically by the Kinesis. So that's why we are going to add that as the trigger here. Select Kinesis, and then we have to give it which stream. Obviously the anomaly detection stream, and activate the trigger. Starting position is stream horizon. I think what this does is it will give everything, I guess, instead of the latest. So all this Lambda function does is it will put the data in the DynamoDB. That's what it does. So once that is done, we can go check the win data table and check if it is actually data if is actually getting inserted into this or not. Okay, so that's what happens. Next page, and you can see this is the anomaly and it is greater than 3. So when we actually run our another lambda, this it should extract these 3 records from the DynamoDB table and then send it to SNS, and then we should get an email. So that particular lambda or not, this is a SNS topic. It's already created, but we have to subscribe to this. I know this is too much, but don't worry. When I do this, you will understand it. I'm going all steps because I already did this. Create subscription. Then I have to give my email here. Create subscription. But that is not going to send automatically. I need to confirm my email address to AWS SNS topic. So I will go to my email, click on that and all that I will show you. Then we are going to go to this anomaly message delivery function. What this does is, this is the bug I'm talking about. You see this in this line, max wind speed. Actually, this column doesn't exist on DynamoDB. Max wind speed does exist, but it is for the DIY table, not for the practice lab table. So there is a bug which we cannot correct it because I cannot update the Lambda function. So we won't get the notifications for the practice lab. At least that's what I want to show you. When I run it, you will see it. And we are triggering this manually. We just create a dummy event and then test it. It did run for them, but in reality it won't run for us because I just explained you that particular column doesn't exist in DynamoDB. I will show you. And then you should get 3 emails with these 3 anomalies. They got it, but we won't get it. Anyways, that's pretty much the DIY is. Now let's go and do this. I know I went super fast over there, but I expect you to pause and read through all the concepts. But since I already did this, I remember what all I need to do. I I hope at least I remember what all I need to do. Okay, now let's go to the S3, and here you can see those 2 names right here. So let's copy that and paste it on my notepad. By the way, the max wind speed is for the um, DIY, but that's fine. Okay, and I think I can close this. Let me go full screen again. So once we did that, they already have an EC2 instance running as I mentioned. All we have to do is open this. It won't open automatically because as you know, we need to change that to HTTP, and also we have to go to Kinesis. Okay, it's running, which is good, but we need to give the stream name, which we didn't create it yet. So let's go and create our data stream, and the names has to match exactly to whatever they give, otherwise this won't work, because this one we have to give that name. Click provisioned, pretty much that's it. There is nothing fancy uh, while creating a data stream. It won't take much time, it will take a couple of seconds and it will be available. As you can see, it is available. Now just to test it, let's give it that, submit it, start. So now it is going to send some test data, and I think it will take some time for us to see it, but how you see it is you go to the data viewer and then you will pick the shard and then get records, and then let's give it couple of seconds. In the meantime, what I want to do is I want to create our another stream, which is the anomaly detection stream. Let's go ahead and create it, then click provision and let's create the data stream here. Okay, this is active as well. Now let's go and create our Flink application. So previously this used to be called Apache Data Analytics for, I think, Kinesis Data Analytics. Okay, we are selecting streaming application and we are going to create from scratch, and the application name we are going to give this is I think it is anomaly detection, and we are going to choose a role which is this one, and it is going to be development, and then create the application. We are going to get this error for some reason, and if I click again it passes. That's weird. and it is ready and that, but let me configure it. And this bucket is the bucket where we have our actual application sitting. And what is the name of that application? It's anomaly detection.jar. And nothing, no changes, no changes here. What we are going to do is we are going to add three runtime properties, and this we are going to group ID is lab, lab, and lab. And the first one is we are going to tell it what is my input stream name, which is my win data stream, and what is my output stream name. Where do I want the data to go after the anomaly detection? Into this particular stream, which I already created it. And we have to also pass the region, which is US East one. I think pretty much that's it. Save changes. And it's been some time, so I can go back to my data streams and go to win stream. And if I go to data viewer, click the shard. And why this shard? Because you see this, right? This is the shard that it is sending the data to. So click latest get records. If you see that, just click next. So I think it already streamed. So let's click trim horizon, get records, and you will see all the records that already here. So trim horizon gives all the records on this stream. When you select latest, if you are getting anything right now, that will show. But I think it stopped sending data. That's why you are not seeing it. Okay. So we have data for that, but we created it for another one as well. So let's go ahead and click to test wind speed data set. Now this is going to send it to the same thing again. I think let's see if I did run this or not. Did they tell us to run it? See, this is a mistake. I think I don't want to make. Okay, let's see. Oh yeah, they ran it and then went ahead and started this one. Okay, we'll see if it is going to have data or not. That's fine. I think it should. Even if it doesn't have the data, that's fine. Anyways, this is not going to run for us because of that problem in the Lambda. So this takes some time to run. So that is the problem, and we already started feeding it data. Okay, while it is running, what I want to check is I want to go ahead and check the Lambda and see that code, at least if they have it corrected here or not. Most probably they won't. Okay, not this one. Yeah, sometimes it does that. Either refresh or maybe I have two open. Maybe that's why it is not doing it. So let me go here. I think that should not be a problem, but yeah, we should be able to open multiple functions at the same time. Okay, while that is going on, this started running and this is still feeding data, so that is good for us. Now let's go to the anomaly detection stream, and I think this will take some time to get some data. So yeah, it is getting data anyways, which is good. So if I do that, it got data, but if you see, it doesn't have that anomaly yet. Most of their score is that because We didn't send an anomaly score at all. So let's, while that is happening, let it do its job. But what I am want to see is why I am not getting this code. And let me go here. Let's hope it will show it right now. Okay, let's wait for some time. Okay, so in the meantime, what we can do. Okay, so this is done sending data, so I am good. Okay, I am good. So what they told us to do after that is, so once you have data in that anomaly stream, then we are going to send anomaly dataset. This will have some values that we are going to trigger the anomaly. And once we do that, we will go to the Lambda function and enable this as the trigger. Okay, so let's do that, but I want to see this code. I mean, come on. If I don't see the code, how am I going to make changes to it? Hmm. Every day I'm seeing something or the other. Anyways, that can wait. So once we have this running, that's fine. Let's go ahead, click the anomaly dataset, and we are going to go to this Lambda function. Okay, let's hope. Let me open this. Okay, now it opened, which is good. Okay, so one thing I want to make sure is, you see this, right? This is this is going to get triggered by our Kinesis Flink or the analytics stream. But what I want to show you is these are the columns that we are going to put in the DynamoDB. And what are those columns? Timestamp, location, wind speed, anomaly. Make a note of this one. It is wind speed. It is not max wind speed. I cannot edit it here. I wish I can edit it and deploy it, but I don't have that. But it is wind speed that we are putting. So when you are putting wind speed and when you are extracting the data from the DynamoDB, you should use the wind speed, not max wind speed. But that is the problem with the other. Anyways, we have it here. We have the configuration, everything set up to the window data table, output table name. So let's click on add trigger. And in this case, we are going to use Kinesis. And Kinesis stream is the analytics data stream. And I think that's it. It's not latest trim horizon, which means it will pick everything. If you pick latest, then it will only pick whatever is streaming right now. But I think we are done sending it, so that wouldn't work. Trim horizon will work. Now let me go here and get records. So I should see some anomaly data in here as well somewhere. No? Yeah, here you see those three records. We got them, which is good. Since I put the trigger here, and it's enabled, I think it should start sending data to, it will get triggered automatically and it should start sending data to the DynamoDB, which is what we will do next. We'll go there and check the data. It might take a couple of minutes, but that's fine. Let's wait for it. And let me go to DynamoDB. This should not take long for it. And tables. So we have two tables. This one has the column max, but this one doesn't. So I can prove that here as well when I explore tables, run it. So you see the anomaly score wind speed, it's not max wind speed. So you need to remember that. So let me click on this, click next. That's it. Oh, I should still see more records. Is it still coming? What's going on? Oh yeah, we got it. Okay, wind speed. I don't know why it is. Okay, so you see these three records, right? So these three records should be picked up when we run the other Lambda function, but for us it won't. Why? Because of the wind speed. It will query max wind speed, but we have it the column as wind speed. Okay, now that is done. The next step in for us to do is go to SNS. In SNS, what we are going to do is go to the topic that is already there, but we need to subscribe to this. Click subscribe. Protocol is email, and we are going to enter my email. Yeah. And then create. If you see, this will be in pending confirmation, and I have to go to the Gmail, and I have to click on this and confirm the subscription. Okay, now it is subscribed. So if I go back to here and refresh this, it should say confirmed. You need to make this the status is confirmed, otherwise it won't get sent to. Okay, now that is done. The next step is for us to go to the message delivery, and what this function does is, okay, seriously, again the same problem. Okay, let's click on test. I wanted to show you that, but it's okay. We are triggering this, so let's create a dummy. It doesn't matter because it doesn't take any input. Let's save it. Let's hope I can see the code now at least. Okay, that's fine. If I test it, this should fail, complaining about it cannot find the max. You can see the max wind speed because it is trying to access that from the DynamoDB, and this one doesn't exist in DynamoDB. So for that reason, it is failing. Key error. It is trying to access that. It doesn't exist. So that's the reason. I wanted to show you in the code, but that's fine. We cannot. But that's about it for the, at least for the practice lab. I thought of showing that, but it's not. But at least try to do that for the DIY. So DIY, it's similar. We just need to create another application, Flink application, and we have to create another stream. But this time we need to make sure that uh, the stream has to be with the same name that they provided. They actually gave that name in here. If you come here, the stream name to should be max wind speed. So let's go ahead. Let's create our stream called max wind speed. Click on provision, create the stream. And they also gave the application name, what the application name should be, and that should be calculate max speed. So let's go ahead and create another streaming application from scratch, and the application name is going to be this. Use the IAM role, same thing, and it is the development. Create the application. Remember what we need to do next? We need to configure it more, and we are going to select our jar file again. Click that, and jar file name I already copied it from that place, so it is this one. And scroll down more. Okay, yeah, items. We have to repeat the same process for this one as well because our data is coming from the same stream. But in this case, the input stream is going to be the wind data stream, but the output stream is going to be whatever stream we just created, which is the max wind speed stream. Yeah, and the region is going to be same, so nothing much there. All right, I think that's about it. Let's save changes. Okay. which are saved. All we have to do is click it, run. What should this do when it will run? Once it runs, we will go ahead and actually start sending the DIY dataset as well. Let's hope that works. But this is not integrated. I don't think it's integrated into SNS, so we won't get any emails. I wished they had this function working. Maybe I should leave them a message. Come on, show me the function. Anyways, I think this should be, oh, it's still starting. Okay. What's going on with this function? Even this, it knows that there is something wrong with this and not showing me. Let me know in the comments if you know what should I do when, even at my work, I see this sometimes, but I want to see the code. One way I can do that is by downloading it. Let me do that. Okay, let me unzip it. Okay, which, seriously, I have plenty of folders. Okay, here we go. Okay, I have the code here. Let me open it with this one. Okay, so this is the line of code that I'm complaining about. They got messed it up with the DIY because the DIY has maximum speed, but that's fine. And all we have to do is change this to this, but unfortunately, they didn't give us right permissions on the Lambda, so we can't do that. I hope this is up and running now, and this is calculate max speed, which is good. Now we need to go to another Lambda function, which is the DIY function. We need to make this get triggered by the Kinesis data stream that we just created. So click that and make sure it is the max wind speed, and that's that, and we'll select trim horizon. But there is no data in this yet. So first of all, let's go and send some data. So the data is being sent to what? Do you guys know? It is being sent to the wind data stream. So what wind data stream does is, I mean, it won't do much. It will just have the data, but the Flink application that we created, which is calculate, which the input is this one. So this is still running. So it will, as soon as the data is real time, this will read, and in real time, the output it is going to send is max wind speed. So let's give it some time, and we should be able to see some data in here. And I won't select, maybe we can select latest as well. I don't know if it already brought data. No, it didn't. Okay, it is bringing data, city wind farm, that's fine. Are those only two records or what? Okay, it's still sending data, so let it. Anyways, but we are getting it. You get the idea. So once that is done, what we are going to do is, yeah, select this add. So this should get automatically triggered, this DIY function. I hope they didn't do any mistakes in here. So pretty much it's the same function as the other one. It is going to put, you can see the max wind speed here, right? And location timestamp into DynamoDB. Where is that? Here. Okay, but not into this table anymore. It should be in this one. Let's go and see couple of more records. Yeah, it inserted few more records. Since we enabled that, let's go here to is this it? Yeah, explore items, and let's run this. Okay, it doesn't have any data yet. Huh, interesting. Okay, now we have it. Cool. I think pretty much that's about the DIY. What do you guys think? Calculate the wind speed for one of the wind farms. Create that, which we did. So they want us to give the DynamoDB table, which is this one. I think they will just query records if they got loaded or not, which should be green. Give me green. Yes, success. You did it. You changed the application to calculate average wind speed and you store the data in DynamoDB. Now return to the city and give your customer the good news. Like, I wanted to show the subscription though in the emails here, but because of that Lambda function, I cannot do that. Only if they gave me the permissions to edit this simple change. But anyways, we successfully finished this. That's all. I hope you learned something because I really enjoyed this um, project because I get to learn about the data streams as well as the data analytics, Kinesis data analytics. Then SNS I already know. It's a just subscribing to it. And what else? Lambda we already know. We have used it in so many projects by now. What else we used? I think pretty much that's it. So if you liked, you know what to do. So let's exit from here and give the good news. Done. You should now be able to quickly respond when high wind occurs. This works great. Thank you for your help. Choose a reward as a token of our appreciation. This all looks okay, fine. Okay, now we know it's time for the feedback. So, as usual, if you haven't subscribed, go ahead and subscribe. If you are subscribed, don't forget to like, share, comment, and turn on that notification bell so that you will get notified whenever I upload these videos. I like this project, so I will give them a 5 star. Again, you might think that, what will my like, comment, share will do, but trust me, it helps this channel a lot because it is going to show it to anybody who searches. YouTube is going to show our video. So indirectly, you are going to help this channel by just uh, liking, commenting. That really helps. The more activity on a video, the more probability of YouTube picking it. So indirectly, you guys are. So it just takes a couple of seconds, 30 seconds max to like, comment, and share. So I really appreciate you doing that. And you can also support by becoming a member or giving super likes, etc. But I really appreciate your time here. So let's go ahead and zap some drones. All right. So we have some drones. Oh, we have one right here. All right. Kinesis Data Analytics for Apache Flink is a fully managed Amazon service that enables you to use an Apache Flink application to process streaming data. Yeah, it is a fully managed. All right. And let's not that one, not that one. Both are orange. Wow, these are all orange ones. Okay, never mind. Which functions can an Amazon Kinesis Data Analytics for Apache Flink application perform? What can I do? It can ingest streaming data to data analytics. Powerful SQL. Use Java, Scala, or SQL to process and analyze. No, it can only use Java or Scala, so it's not this one. Capture, process, and store data streams at any scale. Ingest. Um, I don't know. I think it is this, but I can check. Oh, it can SQL, but come on, that's cheating. I think it is this because when we read, right, it only said Java Scala. It didn't mention SQL, but okay. If it can do SQL, then that's good. Let's zap this one. What is a connector in Amazon Kinesis Data Analytics for Apache Flink? Did we see a connector? built-in visualizations, software components that move data into and out of. I think it is this for some reason. Okay, let's connectors. Connectors are flexible integrations that enable you to read from files and directories. Connectors consists of this. Okay, is that what it is? No, no, I think it is that. Okay, where are they? Okay, here we have more. What are runtime properties in Amazon Kinesis? Yeah, we know this. These are parameters to specify how an application provisions. No, the parameters that can be provided to Flink application. Yeah, that's what it is. No? What? What is the length of time before an Amazon Kinesis data streams application can start consuming data from data analytics for Flink stream? I think it is almost immediately, isn't it? I think that's what it is. I think it is immediately. In records in real time, right? Yeah, I think real time means immediately. That is good. But the previous question stumped me. Let's hope they will ask that question again. That's why we need to double check it. What is the connector? Okay, they are repeating it, so they are out of questions. We already answered this one, so it is this. Um, yeah. So let me try one more and see if it is repeating or not. Yeah, it's done. By default, RDS will retain a backup of DB4. I think it is true. Okay. So let's try to zap an orange one and let's hope we have enough cards for that. If so, Athena SQS, I don't know if we have SQS card. We can check it, I guess. No, we don't have SQS. Oh, I remember it. Anyways, I think that's about it, people, for this project. I hope you learned something. And I hope you can use this knowledge in your project or certification. And again, you can use this in your resumes, these projects. You can put them as you did because you know how to do them. So that's all is needed. And I think you can use these examples in your interviews as well. Okay, so go ahead, hit the subscribe, like, share, comment, become a member, and see you in the next one. Thank you very much. Have a nice day. Peace out.